Hey, welcome to the bonus video. This video jumps off from the main one where I accidentally wrote a test incorrectly, but I thought it would be a really good exploration of test-driven development, or a realistic version of that. If somehow you missed the main one, go check it out here first. TDD in its pure ideal form refers to the practice of writing tests before you actually write any code. You know exactly how you want something to behave, so you test for that exact behavior, and then when you write code, you just keep running the tests until they all pass and you know you've done it correctly. In my experience, it doesn't work out that way. The code we write in the real world is way too complex to think of all the edge cases and possible ways it can go wrong. So usually I like to do them in tandem. Write some code, write some tests, write some code, write some tests, fix issues as they come up, and by the end of it, you know you've covered all the tests and that your code is right, but you didn't have to waste a bunch of time thinking through hypothetical edge cases before you started writing anything. We'll continue with the consistency rule for the main video, write an extra test, and at the end figure out what was wrong with that first test. So with that said, let's get into it. Let's try writing another test. Let's say we don't know anything about the players, but in the case file we know that Colonel Mustard is there. So this time the knowledge we expect to get out is the same thing in the case file. We know that Colonel Mustard is there, but now we've learned that none of the players own Colonel Mustard. Let's quickly write that test up and see if it passes. So over here in our test file, I've written this test. One card is in the case file. We set up the initial knowledge with an empty player checklist and an empty player hand size. And in the case file, we know we have Colonel Mustard. We set Colonel Mustard to a Y. We give this initial knowledge to our consistency rule to get some new knowledge. Then we expect that the new knowledge is equal to this value here. And of course, in the case file, nothing has changed. Colonel Mustard is still a Y. But now we should learn that Anisha, Bob, and Cho all have Colonel Mustard as no's because it's in the case file, not in their hands. If you watched the main video, you know how this works. This squiggly means the test failed. We did not get the knowledge we expected. We expected to get all this new information about the players, but instead we got back nothing. Pause here while we look at our algorithm and see if you can figure out why. Okay, did you figure it out? I'm actually not wearing a watch at all. Well, in our algorithm, we completely forgot to look at the case file checklist at all. So let's make a couple of those tweaks. So when we're checking for Ys in a row, we should see if any player has a Y or if the case file has a Y. Also, when we're setting values, we should set an N in the case file if it's blank. So let's make these modifications over in our code. Going back to the definition of the consistency rule, the first change we should make is after we check whether the card is owned by some player, we should also check whether it's owned by the case file. We do this by looking in the case file checklist for that card and seeing if the value is a Y. We save that to a variable called isOwnedByCaseFile. Then next, we exit the function if the card is not owned by some player and it is not owned by the case file, meaning we don't know the owner at all. The next change we make is after we've updated all the players, we also update the case file. First, we check if the case file has a blank by checking the case file checklist for that card. If it's undefined, then we update our knowledge by modifying the case file checklist to set this card to an N. We should also run the tests again to make sure that they pass. So back here in our test file, the test we just wrote passed. Woohoo! We fixed it. Let's check the first test. Uh-oh, I see some squiggles. Yes. The test failed. We did not get the knowledge back that we expected. But why is that? Didn't we fix this already? This time it's because we wrote the test wrong. We should have actually learned stuff about the checklist, that the wrench and the revolver are not in there. So let's fix this test. Going down here, we expect the new knowledge to be this value. What we forgot to add was the knowledge we should have learned about the case file. Because Anisha owned Professor Plum and Bob owns Colonel Mustard, the case file should have Professor Plum as a no and Colonel Mustard as a no. Now running the test again. Hey, it looks like it passed. Great. So that is something to remember about tests. Just because you test something doesn't mean it's right, because your test itself could be wrong. And that's one of the reasons you break everything down into small bits and think through it carefully on a whiteboard first. Since we developed an understanding of the concepts, it was really easy to find and fix that incorrect test. And if I wasn't rigging this video so we encountered those issues, well, we probably would have just written our test correctly in the first place. Okay, so we did that one consistency rule. Let's try another one. I think this one will be a little bit more complex. So this consistency rule says that a card must be owned at least one time. Recapping again, basically what that means is if there are ends in every single row for a particular card, this time let's not forget the case file, then that last blank cell must be a Y. Breaking down the steps we do as a human when we're executing this rule, we're basically, again, going row by row through every cell in that row, count the number of ends. If we find that the number of ends is one less than the number of columns, then we go back through the row, find that blank cell, and set it to a Y. If there are some ends, but it's not exactly one less than the number of columns, then we don't do anything and we keep moving on. This last row is a case we'll actually hit often because it's the output of the previous consistency rule. Maybe we've found that there's a Y and we filled all the rest with ends, so this row is completely filled out. As we go through this new consistency rule, we'll find that the number of ends is exactly one less than the number of columns, but then when we go through to find the blank cell, there's not a blank cell because there's already a Y there, and we won't do anything. Basically, we haven't updated any information, and we move on. Here's what that might look like as an algorithm. Again, we're going row by row. So for each card C, the count of ends for the players are the number of players for which they have an N in our player checklist map. This time, let's not forget the case file and save that into another variable. If it has an N, we'll save a 1. If it does not have an N, we'll save a 0. Then our total number of ends in the whole row is the number of player ends plus the 1 or 0 for the case file. Now we check if that total number of ends is exactly equal to the number of columns minus 1, telling us that there's one cell left over with a blank or a Y. The number of columns is the number of players plus 1 for the case file, so basically, if count n equals the number of players. If that's true, then for each player, we'll go through its cell. If that cell is an unknown, then we set it to a Y. And again, not forgetting about the case file, if the case file has an unknown, then we also set that to a Y. We, the programmers, know that this rule will only ever set one Y at a time, but we still have to iterate through every player and the case file to find where that blank cell is in order to set it as a Y. For the sake of time, we're not going to go through the tests and everything, but you should write those. So now we've implemented two consistency rules that are kind of the inverse of each other. You may be asking yourself, why are we doing them separately? Our first rule says that a card must be owned at most one time, and our second rule said that a card must be owned at least one time. So couldn't we just implement a rule that says a card must be owned exactly one time? I think it is better to keep them separate because it keeps them simpler. This is called separation of concerns. One rule only has to worry about checking for a single Y, and the other rule only has to check for the ends. It also makes it a lot easier to understand. But more than that, I want to keep them separate for reasons. No, really, reasons. Eventually, later on in the series, I want to add some reasons into the mix so a user can understand why the deducer came up with the fact. And the reasons are going to be different for those two rules. The first rule might say something like, Anisha owns the revolver, so therefore Bob cannot. And the second rule might say something like, nobody owns the revolver, so therefore Anisha must. Keeping these consistency rules separate will make it easier to attach those different reasons when we finally get there down the road. With all that done, I'll see you back at the main video. And when you get there, make sure to act smug like you know something the others don't.